Today we're going to work with completing the square when the value of a is greater than 1. You can use April 30th for your notes. And the note packet should have 3 pages today and go up through example 4. We're only going to add one small thing to our completing the square process. So we're going to start with step 1. When we see the quadratic equation, we want to make sure that we separate it so that the quadratic and linear term are on one side, usually the left, and the constant is on the other side. We're going to use this example as we walk through the steps. So what I want to do is add 15 so that I can move it over to the right-hand side. And now I've completed step 1. Now in this case, the value of a is not 1. In our example, it's 5, right in front of our x squared. We want to look at those two terms, the quadratic and the linear, and we want to pull out a numerical GCF to create a leading coefficient of 1. So basically, I'm going to divide the left side by 5. Normally, we would say 5x, but we just want to pull a number, not a variable. So this will become 5 times the quantity x squared plus 2x, and it still equals 15. Now, we're going to complete our perfect square trinomial. So we need to add the missing value to create that trinomial, and we want to remember to balance our equation. So what we had on the last slide, I made a little spot to complete the square, and I gave that also to the right-hand side to balance it out. Remember, we take the linear term, we divide it by 2, and then we square it. So half of positive 2 is positive 1, and when I square it, we're going to fill in the blank with 1. Now, the only difference is, in the perfect square trinomial, I filled in the blank with the correct number, but on the right-hand side, when you balance the equation, you have to keep in mind that we pulled out a greatest common factor, so we need to multiply the GCF of 5 times the 1 that I completed the square with, so the right-hand side actually adds a 5, not a 1. And that's the only thing that's really different about this process. So from here, we're going to factor the perfect square trinomial that's on the left-hand side. So the two identical factors will be x plus 1. The 5 as the GCF is still coming along, and now my right-hand side is 20. Before we try to square root, we want to divide each side by 5. So that will give me a resulting equation where the constant is now 4, and I'm left with just the quantity squared on the left. Now we'll take the square root of each side and solve for our two roots. Don't forget we have a positive and a negative root, and when we get our final solutions, you want to take that into account. So we'll square root both sides. We'll be left with x plus 1, and it equals the positive and negative root of 2. And to get x alone, we'll subtract 1 from both sides. And now I'm going to separate this into two separate solutions. So the first one is negative 1 plus 2. So I have a root at 1. And in the second solution, it's negative 1 minus 2, giving me a root at negative 3. You should always check your solutions to see if they're valid. And then we write our solution set in our fancy brackets. So example 1, the process should go a little quicker now. So again, we're going to separate this into quadratic and linear. I'm going to simply add 77 to the other side, and I'm going to go ahead and pull the GCF right away. So the greatest common factor is 10, and that leaves behind x squared plus 2x. I'm going to fill in the missing blank. Half of 2 is 1, and 1 squared is 1. But I have to multiply the 10 times the 1 to fill in the right-hand side. So I had 77 that moved over and the existing 3. When I combine all those values, now my constant is 90. And I factored my perfect square trinomial into two identical factors. We're going to divide both sides by 10. And now we can square root both sides. So we'll have x plus 1 equals positive and negative 3. And we'll isolate x by subtracting 1 from both sides. And now we'll separate into our two separate roots. So we have -1 plus 3 and -1 minus 3. So my two roots are located at 2 and -4. In example 2, I'm going to go ahead and add 61 to the right-hand side. And now I'm going to remove the greatest common factor from the 3x squared and the -6x. So there's the 3. I'm going to complete the square. Half of -2 will be -1. And when I square it, I'll fill in on the left with +1. But remember, we have to multiply 3 times 1 to fill in the right-hand side. I'm going to factor my perfect square trinomial. My constant is now 54, and we're going to divide both sides by 3. So I have x minus 1 squared equals 18. We're going to square root both sides, and I think you should see that 18 is not a perfect square. We're not going to make a decimal. We're going to simplify that square root radical whenever possible. So when I do this, I have x minus 1 on the left, but I have positive and negative, and I'm going to separate this into two factors. One's a square, one is not. So I'm adding 1, and as I do that, the square root of 9 is 3. So it's 1 plus or minus 3 radical 2. So in this case, your roots are irrational. We can simply split them apart. So in the solution set, we'll have 1 plus 3 radical 2 and 1 minus 3 radical 2. So your homework's going to be a mix of rational and irrational roots. For number 3, I'm going to separate the terms. Quadratic and linear on the left, constant on the right. So I added 40. I'm going to pull out my numeric GCF of 6. And I keep ending up with 2x in the middle. So half of that will be 1, and 1 squared will fill in the first blank with 1. But then we'll multiply 6 times 1 to fill in on the right-hand side to balance the equation. My two identical factors are x plus 1. And now I'm going to divide both sides by 6. And I do have a perfect square as a result now on the right-hand side. So when I square root, I'm going to have x plus 1 equals positive and -3. And then we're going to subtract 1 from each side. Because these are rational roots, we're going to separate them into two distinct answers. So we have -1 plus 3 and -1 minus 3. And the roots on this problem are 2 and -4, just like problem number 1. In example 4, I'm going to do a little rearranging. So I'm subtracting 2x, and I'm leaving the 152 on the right-hand side. I'm going to pull my greatest common factor and make room to complete the square. So again, half of 2 is 1, 1 squared is 1, but on the right side we'll fill in with 8. 8 times 1. My two identical factors are x plus 1, and I have 160. We're going to divide both sides by 8. And then we're going to square root. Again, 20 is not a perfect square. So as we go through this process, we want to break 20 into two factors. One of those factors has to be a perfect square. I'm going to use 4 and 5. And I'm also going to subtract 1, but I'm going to simplify the 4. So x is equal to -1 plus or minus 2 radical 5. And this one we're just going to split into our solution set. So we'll have -1 plus 2 radical 5 and -1 minus 2 radical 5. Tonight's homework is number 108. You'll see completing the square. A is greater than 1 at the top. There should be 10 questions. If you have any questions while you're going through the notes or the homework, please make sure you contact me, and have a great day.